So, hi everybody, today we'll show you how to implement a simple class buffer queue. It is a class that actually does something, so we'll need to type some code into it. So let's start. Open workspace, first of all, some place to type into. Then, as you know, it's better to work with packages in Cuis to store your own code. So, this is a package of mine where to store test stuff. So open browser. Sort. And I go to find Nicola package. Okay, good. I will implement my new class inside this package. Let's see our plan. Our plan is defined in this document. So we want to define a class buffer queue, which is a queue, which is a classical computer science data structure, but it behaves like a buffer, so it's a limited queue that we need to store just a few elements. And how does it behave? Well, you have an example here. I want to create a buffer queue like this, and I put it into the variable queue. So I say buffer queue of size 4 is a new buffer queue which can contain maximum 4 elements. Then I print it, and you see, there is nothing inside the beginning. There are two messages, fundamental messages defined on this object, Enqueue and Dequeue. Enqueue puts stuff in, so Enqueue, you see, string A goes into the queue. Enqueue string B goes in, but observe, it goes in, the new element goes in the first position of the list. Usually it would be here at the end. We show that we can put in also number and nil, so whatever objects, and you see they go also inside in first position. Then let's see that when we reach the maximum number of elements admitted, that is 4 in this case, and we want to enqueue another object, ciao, the last elements get cancelled and the new elements goes in. That ensures that the queue never grows above 4 elements. Finally, the Dequeue methods return. This was the status of the queue. Dequeue returns the last element, 123, but also removes it. In fact, if we go to print after, you see 123 is gone. Very well. How do we make this? How do we make this object? We will use 3 instance variables: buffer, which will be an order collection; size, which will be an integer and says how long the queue object can be; and note, which is just a string. It's not really fundamental, but it shows us how to use accessors. Implementation strategy. Well, the only 2 things that requires a bit of flavor are the definition of enqueue and dequeue. But we are going to discharge all the work on existing methods, add first and remove last of order collection. Let's see what I mean. If you go to order collection, if you make an order collection, new, Control D, execute, O, Control P prints, a Control Shift quote comment. This in Linux, okay? So this is the status of the order collection. Now let's say O add 1. Let's print it. You see the 1 is inside. O add 2. O P. The 2 is in, but it is in the last position. We would like to insert stuff here in the first position. That's why we use the method add first. Let's say A Ctrl D or Ctrl P and say A now is at the beginning of the order collection, which is good, which is what we want. Let's comment this stuff. The last operation we need to check, because we are going to use it, is remove last. Remove last. What will this return? This will return the last element, which is 2, and cut it from the order collection. So let's see it. Ctrl P, 2, indeed. Then let's go to Ctrl P, this one, and of course it is as we said. Good. Now we have all operation. We need just to describe it into our new class. Let's start our work. I recommend you work with more than one browser at a time. So let's open 2 instances of the browser. So we go here in Nicola package and you click in this pane and you define your new class here, and this class is BufferQ. Ctrl S, save, type your initials, NM, it's me. Are you Nicola? Yes, I am. Okay. Observe that this new class is a subclass of object that is a very simple object at the moment. Now we say that we want as instance variable what we said before, that is, let's go to C, buffer size, see here, buffer size and node. So buffer space size and node, Ctrl S. Then we add also a comment into this class, which I implement a simple queue. Ctrl S, okay. Very well. Now we go to the class side. Remember, in Smlalltalk, everything is an object, and operation are done sending messages to objects. But who makes objects? Classes make objects, and indeed BufferQ is a class. And now we go to the class side and we define a message that is sent to the BufferQ class and create the BufferQ object. So we click here and let's check. We want to create objects in this way. You see, the message of size is sent to the class BufferQ, and so we do it like that. Of size with parameter a number returns what? Well, let's say we do like this. Self Ctrl S. What does this do? Well, self in this case is the class BufferQ, and basic new returns a new object BufferQ with the variable initialized to nil. Let's go to see it. I say Q is BufferQ of size, let's say 4. Ctrl D. Now I go to inspect Q and typing Q, Ctrl Shift I. This is the Explorer, Object Explorer, and you see here buffer, there is size and node, and they are all set to nil. This is what basic new does. Okay, it creates a new object with instance variable initialized to nil. Of course, this is not what we want, and to create a better version of the BufferQ, we do as follow. Again, go to File, Nicola package, BufferQ. Now in the instance part, we go to define a method initialize with parameter a number. Well, in initialize we say that buffer, when initialize our object, we want a buffer is an ordered collection, empty at the beginning. Size is the maximum size of the queue, that is a number. And note at the beginning is an empty list. And now, sorry, an empty string. Control S. Very well. So now we go back to our of size, and we say that after basic new we call the message initialize with parameter a number. Let's check our object creator now. So Control D here, Explorer. Very well. Of size is 4, note is the empty string, and buffer is an empty order collection. Very well. So our initializer is as we want. Now of course we need to add two methods. Before going on, observe this. Of size, self basic new, as we said, create a new object of class buffer queue. Initialized is a message that is defined on the object of class buffer queue. That is why initialize is defined in the instance side of this class. Okay, very well. So Enqueue and Dequeue will be also defined in the instance part. Let's do it. Buffer queue instance side. Here we want to define Enqueue an object. Here I copied the code somewhere else to make it faster. Okay, so what does it do? If buffer size is less than the maximum size, let's check this. You remember size a number, in this case size 4, you see size 4. If buffer size is less than 4, then just add the object an object. But if buffer size, this size, is equal to 4 in this case, then remove the last element from the queue and add the object an object. We return the buffer queue itself. This is not fundamental, but it's good to do it. So let's try it. Control D. Let's explore it. So 1, 2, 3 is in. Control D, Control E. Again, behaving well. Let's arrive to the limit. So now the queue contains the limit number of elements for itself, which is 4. And you see that if I try to add another object, 123 will be cancelled and the new object will go up here. Let's write and here we are. It behaves as expected. So good. Let's now define the method Dequeue. Push here, Dequeue. Dequeue needs no parameter. Observe that this red line around the pane means that the code has not been saved. So to Dequeue here also I prepared the code. What does it do? It takes remove last, which returns the last object from the list buffer, and we return it. I left an exercise you here, attention, because if you do remove last from an empty list, everything breaks, so you need to check the list is not nil. But I leave you this as an exercise, okay? So let's try it. Queue, we can close here. Let's open another Explorer. So Dequeue will return the last element into the list, which is the oldest, which is 1, 2, 3, 4, and remove it. So exactly, and let's explore the object again. Good, it behaves as expected. Be careful, if you remove all the object and you call Dequeue again, you will see the debugger, which is not embedded in that, but just for you to know that you need to add some extra code if you don't want your program to stop when you try to Dequeue on an empty queue. Very well. At this moment we need to add the code only for Note. Well, the code for Note is meant only to show you how to operate on the variable Note, because up to now, if you observe, you have your object queue. Yeah, you can explore it, but you can't, for example, let's say I want to see the buffer size, the variable, the instance variable buffer. How do I do? Well, you don't. You need to use the Explorer. We didn't prepare an accessor to let you change or see this one explicitly, okay? Try buffer, you see, it's red. If I try to control D, it tells me, attention, unknown selector. I don't know how to perform this. It's right. So let's do that for Note, and we do like that for the instance variable Note. We say here that Note return just the variable Note, and let's try now Note is the empty string. And now let's add also a way to modify Note. So Note string is what is that the instance variable Note become a string. Let's test it. For Q, Note is hello world. Of course, what can it be? Let's go to CQ Note. Now it's hello world. Let's go to explore our object buffer queue. Here it is, Note hello world. Very well. At this moment we need to make a little bit of cleaning. So let's clean up. We need to define the method categories, because you see here as unclassified is not nice. Look, the way to do is this: you do new category, and of course instance creation, you take off size, and it is an instance creation message, so for sure it goes there. Then we go to the instance side, same stuff. So these two are accessors because they are used to access an instance variable. So new category, accessing, go here, Note, tac. Then initialize as its own category, initialization, tac. We need the queue and queue. Well, I would say these are proper operation of the class. So new category, new. I would say operation. Very well. So we have defined our class buffer queue. We cleaned a bit. We made all the method grouped into reasonable categories, understandable. So what could you do now? Well, of course, if you want, you can save your work, installed packages. You see here in Nicola package, there is this arrow, that means that there is unsaved stuff. You can do save, and at this moment your buffer queue is saved on the disk. Last thing, third thing you could improve here, you can add a reader for the instance variable size. Then you could add a method count that tells you how many elements are in the buffer queue. You could add a method reset buffer, which cleans whatever is in the buffer queue. And you could implement a print on method. A print on method is for this. You see, if you do Q and then Control P, you get buffer queue. Okay, thank you. It's not much informative. If you go to see, for example, before we had an order collection, if I go to print the order collection, Control P, it tells me more information. It shows me what's inside the order collection. I would like to see the same stuff when I'm working with a buffer queue. So go to see other implementation of print on and copy and try to adapt. Final thoughts, of course this example is made without taking performance into account, so we just want a simple object to do what we expect to do. And also, why don't we subclass order collection? Finally, we use the order collection to do almost everything. So we could say that we could say that buffer queue could be a subclass of order collection with the two methods added, Enqueue and Dequeue. True, but there would be this problem that in the order collection you have already a lot of methods defined, which don't play well with the structure you want to impose to a queue. So that's it for today. I hope you learned something useful. Goodbye.